Hello everyone! Today we'll talk about the solution to the problem make string a subsequence using cyclic increments. This problem is not very difficult, though for some reason I found the statement to be a bit confusing, both about this cyclic shift, about where it happens, so do we shift in string 1 or in string 2, because we have to make string 2 a subsequence of string 1, but we want to make it a subsequence by modifying string 1 and not by modifying string 2, so the shift direction is important. Though in this code, this thing will just change and swap this value here, C, with this value here. So that at least doesn't matter, but you have to check it, that you understand it correctly. And also the fact that you have to perform the operation at most once. However, the operation is to select a set of indices and perform this simple operation on every index, which means that we can essentially perform this operation at most once at every position we want. So that's also maybe confusing. However, now that we know that we can perform the operation on any position we want, but we can only perform it 0 or 1 time, we know that, well, we can just try to greedily match this string that we want to be a subsequence with our string that we have. And to do so, of course, if we couldn't perform any operations, we would just have to match it whenever we go character by character in both strings. And whenever we see a matching character in string 1, then we are happy, and we progress to the next character in string 2 and the next character in string 1. Otherwise, we have to skip that character in string 1. And here the only difference is that the characters that we accept is not just the exact same character, but also the character that was previous in this cyclic list of characters. So when we see B in string 2, we accept B or A in string 1. And this is the only difference. So we'll be remembering the next position in string 1. We'll be going through all the characters in string 2. And whenever we fall out of string 1, we have to return false because we run out of letters. And of course, for as long as we haven't matched, we cannot accept this character for our character in the subsequence. We have to increment our I. And of course, we have to increment our I after all of this as well, because this is indeed the character that we want to match with our character C in string 1. And this portion here, of course, checks if the character is compatible. So normally we would just check if string 1 of I is equal to C. But now I'm creating a dictionary for all the compatible letters, and the compatible letters for C is C itself, and also the character for which C is the next character, and we can, for instance, zip all the lowercase letters with the lowercase letters shifted cyclically by 1. So this is ASCII lowercase starting from position 1, so skipping the 0th element plus that 0th element, and by zipping them we create those pairs. So for A we have A and B, and so on. And this is essentially all that we need to do. And this is a very standard approach that you should solve the problem like this greedily, and it's easy to show why the greedy approach is the best. Because whenever you are in a situation where you have consumed some letters from string 1 and matched them with some prefix of string 2, there is never a point to match fewer letters from string 2. So you always want to match whenever possible, so whenever this compatibility arises, because in any position you are only interested in how many letters you've taken from string 1 and how many letters you've taken from string 2. And if somebody else offered you a different solution that does the same thing, so that ate some letters from string 1, but has progressed not that far in string 2, so their prefix of string 2 that's already covered is shorter than your prefix, then you don't care about their solution. You can essentially, because your solution is better, your solution covers a longer prefix at that by using only the same set of letters from string 1, or looking at it from a different perspective, when they cover a longer prefix of string 2, the prefix that's the same prefix that you have covered, they have used more letters from string 1. So you can simply take their solution and cover this first part like you did, and then continue with the rest like they did, and this is also a correct solution. So this is a very standard approach of proving that a greedy works, and in this case this is an example of a simple proof of exactly that kind of property.